acceleration is a non-science word. Okay? You won't get dinged for using it, but you will get dinged for not realizing that deceleration is a type of acceleration. Okay? All right, so there is A, B, D, and E. And how do you know that they're accelerating? Huh? Because they're not flat. Yeah. On a velocity graph, if you see a change in velocity, or actually any graph, where you see a change in velocity, it's acceleration. Okay? All right, during which interval is the acceleration the greatest? Why? It's the steepness, right? The steepness is the biggest, or you could say the biggest steepness or the greatest slope, either or. Thank you for asking on that. Yeah, this, like I said, this is pretty much a notes type of assignment, so we're not going full-on answers. We're not doing a full AP style. We're just, do we know the answer or not? Okay. During which interval is the object standing still? Josh? Huh? Why? Yeah. Yeah. There's only one place on a velocity for it to be still. That's where velocity is 0. And there's nothing down there. And finally, which interval or intervals does the object have a constant speed? Flat, right? Okay. So constant velocity on a velocity graph is flat. Now let's flip it over. Okay. So just to jump ahead and give you the homework assignment, the homework assignment is going to be to draw the acceleration graph. Well, we're going to get through most of E through J right now. All right? So it's to draw the acceleration graph. Again, that acceleration graph is exactly like the position graph. It's just position is velocity over time. What's acceleration? Sorry, velocity is displacement over time, and acceleration is velocity over time. All right? So the slope of the position graph is velocity. The slope of the velocity graph is the acceleration. Probably tomorrow or the next day we'll actually write some of this out a little bit more as notes. But for right now, this is process notes. Okay, so E through I are asking for displacement. Okay, so displacement is another way for saying how far, and how do you determine that on a velocity graph? Area under the curve, right? Okay, I am going to show you area under the curve on B, simply because it's slightly more complicated than doing it on A or C. Okay, let's discuss that. So first thing, if you've got to do a how far, you figure out your displacement, and you have a line that goes all over the place, you break it into segments. And so let's do that really quick. Let's go through, and we're going to draw lines, and we're going to turn this into segments. So here's segment 1, just so we can clearly see what they are. So there's segment 1, or A. Here is segment B. You can do this yourself. C. D. And E. Okay? So what we're going to do is we are going to calculate the area under the curve for each segment. Okay? At the end, this is not a question on there, but you're going to do this as your double check. You're going to find the total displacement. Okay? So, how do we do any of this? Area under the curve. A is easy because it's just a triangle, right? Okay? C is easy, it's just a rectangle. If you've got B, D, or E, if you can remember the formula for a trapezoid, have fun. I left that information out of my brain. So I'm going to break B into 2 pieces. I'm going to break it into a triangle, and I'm going to break it into a square. I'm going to call this one B1, and this one B2. And yes, I do understand that by the time I'm done with this, you'll say, I could do this a whole lot faster. Why are you writing it out like this? I'm writing it out like this so everybody can see the actual steps that go into it, even if you can do it faster. Okay, so if I want the entire area, I need to find the area of B1, the area of B2, and the total would be add them together. So the area of B1 is basically the displacement of B1. B1 is a triangle, so it's 1/2 base times height. Okay, and that's 1/2 of 5 seconds. All right, what I'm looking at here is I'm going, 1, 2, 3, 4, 5 seconds, and then I'm going to go up, my change on my height is 10 meters per second. So I'm going to do that. 1/2, 5 seconds times 10 meters per second. When I do that, you see my seconds cancel out, and I'm left with 50 times 1/2, which is 25 meters. Okay, now I'm going to do the area for B2. That will give me my displacement for B2. That's a square, length times width. Okay, so I've got a length of 5 seconds. And I have a width of 1, 2, 3, 4, 5 meters per second. So units cancel. 25 meters per second. 25 meters, sorry. Seconds cancel, we're left with meters. My total area for B2, there you go. No, you're adding them. All right, because you're adding them, it's just meters. But what we're doing, yeah, B is the delta X for B1 plus the delta X for B2. All right, we already did the multiplication, and that canceled out the seconds. So now it's just, this is the area. Okay. So it's 25 meters plus 25 meters. And that equals 50 meters. Okay, lather, rinse, and repeat for A, C, D, and E. I want to say it's 307.5 is your total displacement. Okay? For when you're done with everything. So if you want to find out how far it took, how far it went from the initial time to the final time. So in 30 seconds, this object moved 307.5 meters. That's your double check. If you need to add up all of your displacements together, all right, and you're going to find the total displacement.
That was just for A, right?
That was for B.
Oh, B means
Yeah. And we did B